All right, welcome to Next Gen Manufacturing. Today we're talking about a material that's so common you probably don't think twice about it, aluminum. But here's the thing. In today's world, mastering the easy stuff is exactly how you get a serious competitive advantage. So we're going to break down how you can machine aluminum faster, smarter, and a whole lot more efficiently. Let's dive in.
So here's our game plan. First up, the aluminum advantage. Then we'll get into why you've got to know your material. After that, it's all about choosing your weapon, your tools. Then we'll cover some next-gen machining tactics, and finally we'll pull it all together to talk about the competitive edge. Okay, Section 1, the aluminum advantage. And really, this is all about the paradox of an easy material. You'll see what I mean. The very thing that makes aluminum so great is also what makes it a massive challenge. I mean, think about it. Aluminum is absolutely everywhere. It's super lightweight, you can form it into pretty much anything, which is why it's a top choice for, well, everything from quick prototypes to huge industrial parts. It's basically the workhorse of modern manufacturing.
And on top of all that, it has excellent machinability. I mean, it cuts like butter. It's not some tough, exotic alloy that's going to fight you tooth and nail. So what's the problem, right? If it's so easy, what's the big deal?
Well, that's the kicker. The problem is intense competition. Whenever a material is easy to work with, it means everyone is doing it. So the only way to actually win is to be faster, smarter, and more efficient than the next guy. That's the whole game. Which brings us right to our next section, know your material. Because before you even start thinking about cool toolpaths or high speeds, you have to get this one thing straight. Not all aluminum is created equal. Not by a long shot.
So you've basically got two main flavors, wrought and cast. Think of it like this. Wrought aluminum is the premium stuff. It's got higher tensile strength, it machines beautifully, but yeah, it's going to cost you more. On the other hand, you've got cast aluminum. It's less expensive, a bit more flexible, but, and this is a big but, it's way more abrasive on your tools, mostly thanks to stuff like silicone they mix in. Just knowing which one you're cutting is like step one to not destroying your tools and wasting time.
Okay, that leads us perfectly into Section 3, choosing your weapon. Once you know what you're up against, material-wise, you need the right tool for the job. And believe me, in high-speed machining, it is all about the geometry of speed.
All right, let's talk flutes. For like ever, the two-flute end mill was the go-to for aluminum. It makes sense, right? It's got these huge gullets that let those sticky aluminum chips just fly out. It's kind of the old-school safe bet. But then you've got the three-flute. Now this is where things get interesting. It's awesome for finishing, but if you dial in your parameters just right, you can use it for roughing too. Suddenly you're looking at much higher material removal rates. It's a move away from the traditional way to a much more versatile, high-performance strategy. Now let's get a little geeky for a second and talk about the Helix angle. This is super important. Basically, it's just the angle of the spiral on the cutting edge. Think of it like the threads on a screw. This angle completely changes how the tool slices into the material, and maybe even more importantly, how it pulls the chips up and out of the cut. And there's a whole spectrum to choose from. A 35-degree angle? That's your workhorse, your standard for roughing and slotting. 40 degrees is a really nice, balanced, all-around option. But that 45-degree angle? Oh, that's where the magic happens. It gives you an amazing finish, and it's the absolute best choice for the next-gen stuff we're about to get into. It creates this shearing cut that's just perfect for insane speeds. All right, Section 4. We know our material, we've picked our weapon. Now it's time to talk about the tactics that really push the limits. This is where we get into some real next-gen stuff.
Okay, two key pieces of tech you absolutely need to know about. First up, chip breakers. The name says it all. They literally break those long, stringy, annoying aluminum chips into tiny, manageable pieces. Why does that matter? Because now you can crank up your speeds without clogging everything up. Then we have high-balance end mills. These things are engineered to insane tolerances, perfectly balanced so they can spin at ridiculous speeds and not, shake your machine apart.
And when I say ridiculous speeds, I mean it. In the right machine setup, these tools can hit 33,000 RPM. That is just flying. And that kind of speed is what next-gen manufacturing is all about.
So you might be asking, how in the world do you actually use that kind of speed? Well, you do it with a strategy called high-efficiency milling, or HEM. The whole idea is to flip traditional roughing on its head. Instead of taking a big, deep bite with just the tip of your tool, you take a really small bite sideways, but you use the entire length of the tool's cutting edge. It's more like high-speed shaving than old-school gouging.
Let's walk through that. First, a low radial cut. That's your small step to the side. Second, a high axial cut. That's engaging the full length of the flute. And third, what does this do? It maximizes your tool edge. You're spreading out the heat and the wear over the whole cutting surface instead of hammering one tiny spot. Your tools last way longer, and you can run at those insane speeds we talked about. It's a total game changer for material removal.
And all of this is what brings us to our final section, the competitive edge. This is where we bring it all home and connect these geeky tech details to what really matters, running a profitable shop.
Remember when we talked about cast versus wrought aluminum? Well, look at this. This is what that difference looks like in the real world, measured in surface feet per minute. For cast aluminum, you're looking at maybe 500 to 1,000 SFM. But with wrought, you can push that up to 1,500. You can literally run almost twice as fast. If you know this, you can program your machines for maximum performance instead of just using some generic setting that leaves a ton of speed and money on the table.
And this quote just nails it. Optimizing your tool crib, machine setups, and tool paths for aluminum is essential to stay ahead of the competition and make your shop more efficient. It's not about one single trick. It's about looking at the whole system, your tools, your setups, your software, and making sure every single piece is working together perfectly. Because at the end of the day, in next-gen manufacturing, the difference between winning a job and losing it really comes down to mastering these tiny details. The winners are the shops that get it. They understand the material, they pick the absolute perfect tool, and they use cutting-edge strategies like HEM to get every last ounce of performance from their equipment. So I'll leave you with this question to chew on. We're already talking about 33,000 RPM, using strategies that would have sounded like science fiction just 10 or 15 years ago. So as this tech keeps getting faster and smarter, what's next? What does the future of precision manufacturing even look like? What new level of speed is going to separate the best from the rest tomorrow?